And so obviously the discussion point today is going to be IOTA. So the way that I structured this presentation is that it's more focused on what IOTA is and how it works and how it's actually different from a blockchain. And so this is not really about our ecosystem or the corporate partnerships that we have ongoing. And it's more about to give you guys a concrete understanding of how IOTA works and so that you can better also assess its potential. And in the end, I will discuss some use case that we're currently working on. Now, this is more a technology discussion for now. So a quick introduction about myself, actually. So I'm one of the co-founders of IOTA, and currently with David, I lead the non-profit foundation, which is being set up in Germany. And so I've been for 5 years in this blockchain space. I started out in 2011. I actually started out with mining, quite ironically. And then with the money that I made, I had a few blockchain startups, most prominently one in Switzerland, where I helped build this crypto valley in Zug, which is now kind of the mecca for ICOs. And kind of probably the most important aspect about myself is that I'm not delusional, because you guys probably know this blockchain space is incredibly hyped and there's too much bullshit going on right now. And I argue that it really myself and the IOTA team in general is very pragmatic and focused on delivering and actually building real life products that get adopted. So let's jump right into it. So the main thing that really excites all of us here, I guess, is this intersection of blockchain and the Internet of Things, because obviously the Internet of Things is this ubiquitous computing platform where all of our devices are connected. But the thing is, IoT is still not there yet, because we still have huge issues to solve, prominently, most notably, the security of things. Because you probably know or you're probably aware of some of the DDoS attacks that recently happened, where some webcams, I think a few 100,000 webcams were simply hacked and then used to DDoS websites. And it is just a huge threat if you think about IoT really growing exponentially and billions of devices being connected. And the same actually applies to blockchain, because by the way, just for reference, I mostly use blockchain and distributed ledger interchangeably, simply because they're kind of the same, but blockchain is obviously more specifically focused on a subsection of distributed ledgers. But I'll try to use DLT as an acronym. But when it comes to blockchain, obviously blockchain is also not there yet. So we have some big issues to resolve, most notably scalability and transaction fees. And as you've probably noticed what happened with Bitcoin lately, that is not really a way to solve scalability. Like there's still a lot of research to be done, especially when it comes to transaction fees, because I would argue that aside from scalability is one of the biggest bottlenecks of any blockchain out there today. And obviously, when it comes to this intersection of enabling blockchain and IoT to marry together, we have some specific hardware requirements, because IoT is all about resource-constricted environments. And blockchain, as you probably know, I think the Bitcoin database is now more than 120 gigabytes, and Ethereum is getting close to 200 gigabytes. So that really doesn't fit into this realm of IoT. And so knowing that and having the background that we had, because the four founders behind IOTA have been in this blockchain space since 2010, 2011. And for example, Sergey Vancheglo, or more commonly known as Come From Beyond, actually developed the first full proof-of-stake implementation with NXT. So we are quite pioneers in this space as well. And with this knowledge and this wisdom, if you can call it, that we've accumulated over the years, we started working on a completely new architecture. And that was back in 2015. When we realized, hey, this IoT and blockchain really makes a lot of sense, but blockchain, the architecture itself is simply not suited for it. And exactly because of that, we've developed the Tangle. And so how does IOTA actually work? So the main innovation behind IOTA is the Tangle. So you can see the Tangle as a completely different architecture compared to a blockchain. We always joke that the Tangle is a blockchain without the blocks and without a chain. So if we discuss semantics, it's not really a blockchain, but it's really a distributed ledger. So one thing that you have to keep in mind about IOTA and about the Tangle is that it's still the same principles still apply. So the Tangle is still decentralized, it's still a peer-to-peer network, it's still an append-only database, and it still has some way to achieve consensus. And so with that background wisdom, let's jump into how the tangle actually works. So when it comes to IOTA versus blockchain, there are two main differences that I would like to emphasize. The first one is the database structure, and the second one is the consensus approach. So when it comes to the database structure, obviously a blockchain is a sequential chain. We have block after block after block where transactions are aggregated into a block and then continuously appended and confirmed in a certain periodic time. So for example, in Bitcoin, every 10 minutes we get a new block. Or in Ethereum, roughly every 20 seconds, we get a new block. This means that we have those cycles in the blockchain. And when it comes to IOTA, we no longer have those blocks and we no longer have this chain. But what you see here is really independent transactions. So each block here is a transaction. And as you see, those transactions are really interlinked. So one transaction references two past transactions directly, but it also indirectly references this entire subtangle here. And obviously, instead of calling this a blockchain and instead of calling this sequential graph, sequential chain, IOTA is a directed acyclic graph. And if you, for example, know Git, IOTA has a similar structure like that. For those of you that want to dive into more technical details, you can also read our white paper. And obviously, the second distinction of IOTA versus blockchain is the consensus approach. The way that it works in a blockchain is that you have those miners. So those miners are kind of special users. And what they do is they race against each other to secure the blockchain, basically to find the next block, to get the mining reward, and through that to then validate the transactions and to build the block, obviously. But this means that the majority of the network is not actively participating in the consensus. And instead, when it comes to blockchain, the consensus is decoupled from the transaction-making process, which obviously brings with it quite a lot of disadvantages, because now those miners are kind of the gatekeepers of the blockchain, and they can also arbitrarily, obviously, increase transaction fees. Like for example, what you see with Bitcoin and their spamming, that is also miners deliberately doing it because they have the power to not have to worry about too high of a cost for this spamming, simply because they can confirm their own blocks and get the transaction fees from that. So that's quite risky if you think about securing a completely global and decentralized network. So when it comes to IOTA, we always say that IOTA, in IOTA, the transaction-making process and the consensus is no longer decoupled, but it's an intrinsic property of the protocol. So what this means then is that IOTA no longer has miners, but instead every network participant that executes a transaction actively participates in securing and in securing transactions and in validating transactions. So how does this transaction-making process actually look like? So it's basically 3 steps. The first step is obviously that you sign a transaction. And this step can be done by any tiny IoT device. We already have some prototypes for some EC cards that you can simply swipe and it instantly signs the transaction and then sends it off to the merchant. The second step is the tip selection. So the tip selection is one of the most crucial components of IOTA because it's really there to determine the security of the whole system. So the tip selection, just for reference for you guys, a tip in IOTA is an unconfirmed transaction. So those gray blocks here, they are tips, basically. And the tip selection algorithm utilizes Markov chain Monte Carlo, MCMC, to randomly select 2 transactions in this graph that you're going to validate. And part of this tip selection process is then obviously also the validation. And what this validation means is basically you check the signatures of the transactions, you check if it's according to the protocol's specification, and most importantly, you check this entire graph if there's any double spend. So let's say that we are attesting to these 2 transactions, then we're checking this subsection of the tangle to check if there's any conflicting transaction. If there is a conflicting transaction, by protocol, we are disincentivized to validate these transactions because if you validate invalid double spends, for example, someone else will come along and they will no longer confirm your transaction. And as such, you have this incentive, if we can call it, of being honest, of not being honest in that sense. So really, you're really incentivized by the protocol to act honestly and to validate valid transactions. And that's it, basically. So it's as simple as that. So the last step, apart from the validation, is then a proof of work. And this work is cannot really be compared to Bitcoin, because in Bitcoin, it's done every 10 minutes, where those miners basically race against each other and they waste a lot of electricity. In IOTA, this proof of work is similar to Hashcash, where it's being utilized for the spam and Sybil resistance, so that someone cannot make infinitely many transactions per second and thus crumble down the entire network. So after you're done with these three things, you can broadcast your transaction. You will basically attach it to the tangle here, and then someone else will come along. They will execute the tip selection algorithm, and then they will randomly get your transaction and validate it through that. And as such, your transaction just got confirmed. And that's basically it. So that's how you make a transaction in IOTA. You're no longer involved with any miners, and you basically directly are involved in the validation and in securing the entire system. So because of that, the beauty of the tank is that it's much more decentralized, because not just a subsection validates, but the entire network validates. So now we get to the hardcore stuff. So let's discuss consensus in IOTA. So by the way, when it comes to this right now, because I want to be this more interactive, are there any questions so far on how this works? I guess not. All right, beautiful. So let's continue to the consensus part, because that is really crucial to understand. So the biggest question in any distributed ledger is, when is a transaction confirmed? So this concept is called transaction finality. And in for example, in blockchains, you achieve this transaction finality by having more blocks, basically confirming the previous block. So for example, in Bitcoin, you have this heuristic that says that after 6 blocks, there's a negligible probability that someone can double spend or reverse transactions. And as such, you can be sure that after 6 blocks, your transaction is properly confirmed and it cannot be reversed unless someone has really a lot of money to waste on hashing power. And as such, in Bitcoin, you have to wait roughly 1 hour to have full security for your transactions. In IOTA, this is not such a static thing, like being able to say, hey, after 6 blocks, your transaction is confirmed, but instead it's much more fluid. So what you see here is this graph of transactions. So we have green marked transactions, red marked, and gray marked. So as I mentioned previously, those gray marked transactions are their tips. They're right now unconfirmed transactions. Those red marked transactions, they're transactions which have received some kind of confirmations from those tips and from other red transactions. And those green transactions that you see over here, they are basically the global state in IOTA. So they are the transactions which were fully confirmed by all of the newly made transactions. And they are the transactions that, or that kind of transaction status is what we want to achieve. So the biggest question in IOTA is obviously, how do we get from green, from gray to green? And how do we know that if we are in this intermediary stage, at what point in time we will get to this fully confirmed status? So the beauty of IOTA is that consensus is parallelized. So in a normal blockchain, the confirmation of transactions is serialized, so that they're basically confirmed in steps. Every 10 minutes, transactions get confirmed. In IOTA, this is much more decentralized and it's actually parallelized. So this means that if you make a transaction, other people make transactions and collectively confirm transactions. As such, the only way to get from gray to green is by having other people actually confirm transactions. And what this means is that the more active the IOTA network gets, the faster transactions go from gray to green, to full confirmation status. And so now when it comes to asking the question, like how do you know the current confirmation status? There is actually a very beautiful way to approach this in IOTA. So as we mentioned previously, there's this tip selection algorithm. And so let's create a basic scenario. So let's say that I'm a merchant and one of my customers just sent me this transaction a few seconds ago. So I received this transaction. And so now as a merchant, I start listening in on the entire global IOTA network. Because obviously as a merchant, I don't care about the full history that has happened so far. I only care about the network actually validating these transactions. And as you see right now, this merchant is actually utilizing a light client. So we are listening in on the entire global IOTA network right now, and we see transactions flowing in. So now when I want to check the confirmation status of this transaction, I basically execute the tip selection algorithm. So I execute the tip selection algorithm once. So then I get these two transactions from the tip selection algorithm. So now what I do is I go down this path of this transaction to check if it has indirectly or directly validated my transaction. And if we go down this path, we can see, hey, like this transaction indirectly attested to my transaction, and as such, it's starting to build up the confirmation status of my transaction. And it's actually not the same with this transaction. This transaction has not attested to my transaction yet. So this means I executed it twice, and right now I have a 50% probability of my transaction being confirmed because I executed it twice, one transaction confirmed it, and the other transaction didn't confirm it. So now, obviously, what you as a merchant, what you want to do is you want to execute this tip selection algorithm a few hundred times, for example. So let's say we execute it 100 times, and 50 out of those 100 times, those most recent transactions have a path to my transaction. This means that my transaction has the 50% confirmation status. But as time progresses, it basically means that your transaction will never be confirmed by the network because it was a double spend or it was a conflicting transaction or whatever. But most of the time, obviously, your confirmation status will increase over time until it reaches really 99% scenario. And as such, your transaction just got fully confirmed by the entire network, and that is then the global state of the IOTA network. And the beauty of this setup is that you as a merchant can determine when you accept a transaction. Let's say, for example, that it's just a micropayment. And if it's a micropayment, I can say, hey, like, I'm already going to accept this transaction if only 50 out of 100 transactions confirm it, simply because I'm willing to take this risk just to get a transaction accepted faster and to execute a trade. Or if it's a high value transfer, you can say, hey, like, I will only accept this transaction if 100 out of 100 transactions confirm it and have a path to my transaction. So does this right now make sense? Because now I have to explain the CAP theorem as well for my clarity on the scalability of IOTA. Does anyone have a question so far on consensus in IOTA?
Dominik, there's a question on the IM thread. Tom is asking, why does a transaction confirm only 2 tips? Wouldn't it be better to confirm 3 tips or better scalability in case of transactions per second increase and then decrease significantly?
Right. So basically, we ran a lot of simulations and figuring out whether we should make it possible for one transaction to confirm 3 tips instead of just 2. But after the simulation, we kind of came to the conclusion that when it comes to the scalability of the entire network, that attesting to 2 transactions is kind of this equilibrium. So it's the most optimal route that we've taken so far. But to be honest, it's also kind of arbitrary because that is what we've seen so far. And you could do it with 3 transactions, so that one transaction references 3 transactions. But I would argue that is more difficult than to kind of optimally optimize the entire global IOTA network. Because what you have to realize is that when it comes to IOTA, one of the important things is that we have to take the width and the depth of the tangle into account. And what we've seen is that when it comes to regulating this width and the depth, the 2 tips is kind of leads to the best way to optimize it. And that is also taken into account into the MCMC strategy of finding the best tips to select and to confirm, basically. Yeah. Any other questions? Because also I'll quickly dive into the CAP theorem and then about our vision. Okay. So the CAP theorem is a very important theorem that the people in this blockchain space have to know, basically. So the CAP theorem basically says that a distributed system can only achieve 2 out of those 3 properties that are listed here. So there's consistency. So basically we have a database where everyone has the same data stored. So every node in the network has the same data. So this is basically this global state that we always say in blockchain. This availability is that if you make a request to the database, that you get a return value. And partition tolerance means that if there's a faulty process, a network outage or whatever, that you can branch off the database and get back into it without any partition errors or whatever. So that it's a fluid interaction of going offline and going back online again, while still retaining the data. So when it comes to blockchains, though, blockchains focus on consistency and availability. So the problem of focusing on hard consistency is that you impose this global state on the entire network. And because you impose this global state, you can't really scale it that well. So even though there are most blockchains have more rigorous consensus requirements, because of that, they're not able to scale that well. But obviously also when it comes to, for example, the mempool or something like that, there's still this kind of stage when not every node in the network has the same state. But when it comes to the confirmation status, obviously everyone is argued to have the same status, the same data locally. And in IOTA, instead of focusing on this hard consistency, we focus on availability and partition tolerance. When it comes to consistency, we argue that IOTA really utilizes this concept of eventual consistency really, really well. Because obviously what eventual consistency means is that after some period in time, everyone has those green transactions. Everyone has the global state in this cluster, obviously, because the way that IOTA is going to transition in the future is that we will have different clusters in this whole mesh network. So this concept of eventual consistency means that not everyone has, for example, those red blocks yet, because they weren't propagated to the entire network. But this means that still a smaller subsection of the network, meaning those clusters, can validate those transactions and can start building up the whole confirmation status. And because of that, because of not imposing those hard requirements on which transactions you need to store locally and be synchronized with, IOTA is able to scale much better than any other blockchain, especially when it comes to high throughput environment, because the IOTA tank is basically able to adapt to such environments where a subsection of the entire network is able to partition off and make transactions in this high throughput environment where they have a few thousand transactions per second, for example. And this partition tolerance is quite unique in IOTA, and I'm actually going to describe it in more detail afterwards and why it's so important. So why is IOTA awesome? So the main thing about this new approach of achieving consensus is that we no longer have any transaction fees. So this is actually really one of the most unique features of IOTA, being able to send 1 cent and actually receive 1 cent. Because obviously there's no intermediary, there's no miner to take a cut. Instead, it's directly peer-to-peer, machine-to-machine, and no transaction fees involved. And the main reason why this is so beautiful and why so many companies are reaching out to us is because obviously companies want to start making money building stuff on top of a distributed ledger, building applications that actually make money. But the problem is, obviously, in this whole machine economy concept, we're talking about micropayments. And when it comes to micropayments and the blockchain, you have this uncertainty of how much money you're going to get. Because obviously the transaction fee is not determined beforehand, but it's determined afterwards. Even though you can say, hey, I want to give this much in transaction fees, you don't really know if your transaction is going to be confirmed in the end. And as such, you have this uncertainty of how much money you're actually going to get. So imagine sending 1 cent and you pay 50% of that in transaction fees just to get the transaction confirmed. As such, you as a merchant, you no longer know if this business, if this economic transaction is actually viable, if you actually make money on top of it. And with IOTA, we actually give businesses and companies this predictable outcome. They know, hey, I'm going to receive exactly 1 cent, and I'm going to send this resource for exactly this economic transaction, for example. And this predictability is really crucial in getting this whole blockchain space away from proof of concepts towards production-ready applications. And one of the main selling points of IOTA is its scalability. So the beauty of IOTA is that it actually scales horizontally. What this means is that the more nodes are added to the network, the more transactions we can get confirmed per second. Which is why we always show this graph over here, for example. Because the thing is, in a blockchain, the blocks get fuller, and as such, a larger portion of the network can no longer get their transactions confirmed. In IOTA, it's actually the opposite. The more transactions are made, the more network participants we have, the more transactions we can actually confirm. And as such, especially when it comes to executing your applications on top of IOTA, this fits really well. Obviously, because the more applications that run and on top of IOTA, the more transactions we can confirm, and the more suitable it is for your application. And the same actually applies to transaction times, because in blockchain, as I mentioned previously, you have the static value, basically saying that after 60 minutes, your transaction is fully confirmed. In IOTA, it's much more fluid. The more activity we have, the faster your transactions get confirmed, which is really powerful. And to quickly discuss this partition tolerance is that obviously the Internet of Things is an asynchronous environment. So we don't have a global network, but instead we have mesh networks, we have clusters that utilize different network protocols. And IOTA is able to mimic this asynchronous environment by allowing this partition tolerance. So what this means in IOTA is that you're actually able to branch off the main tangle. You're able to form a cluster locally. So let's say, for example, we have a smart home, and the entire smart home just went offline because there was a power outage. But because we have a photovoltaic system, we are able to still get the solar power from our neighbors. And instead, we form our cluster with our neighbor. And so now in this local Tangle environment, I'm able to still transact with my neighbor and pay him per kilowatt that I'm buying off of his power supply. So we still transact, even though we're not connected to the global network. We're still able to transact and make transactions locally. And when we have a network connectivity again, we can simply go back on and again, branch in. And as such, the entire network then confirms those transactions. And that's it, basically. So now our transactions got fully confirmed by the entire network. And they're seen as if we've never been offline in that case. And as such, this is really crucial for the Internet of Things, because obviously Internet of Things, like I mentioned before, is all about resource-constricted environments. And IOTA is able to beautifully mimic this. And another reason why IOTA is awesome is because we are setting up a non-profit foundation in Germany. So right now we're in the final stages. One of the crucial or one of the very interesting things that we are doing is we are actually the first to fully fund this foundation with tokens. So those IOTA tokens. And what the IOTA Foundation is there for, it's really there to develop, and most importantly, it's there to standardize distributed ledger technologies. So one of the things to emphasize is that obviously we started out with IOTA, but we have a vision for an entire IT stack that we're going to develop to truly achieve this vision of a machine economy that we have. And the IOTA Foundation is also going to progress with some major announcements at the end of the year, in terms of the partnerships that we've been setting up over the last couple of months. So let's discuss our vision. I'm going to discuss this for another 10 minutes and then leave another 15 minutes for Q&A afterwards, I think. So the main reason why we actually developed IOTA is not because of cloud computing, but because of fog computing. So the way that IoT is going to transition is that it's no longer going to be about, hey, my smart home hub is connected to the cloud, but instead your smart home hub, your light bulb or whatever is going to be connected to a fog computing station. And what those basically are, is basically all about making decisions locally in real time. Because the problem of the cloud is that we have network congestion, we have propagation delays, and so on and so forth. And there's such an IoT device or billions of IoT devices sending data to the cloud is never going to happen. But instead, we need to make decisions locally in real time. And IOTA basically sits in this local environment, which we obviously call the fog and mist computing. So the beauty of this fog and mist computing vision is that it's not just about sharing data, but it's also about sharing resources. And because of that, we always talk about IOTA being at the crux, at the core of the smart decentralization. So we need to move away from the centralized systems that are powered by the cloud, where the cloud is the decision maker, and instead transition towards those smart and adaptive networks where we make decisions locally in real time to get this emergent intelligence. And the way to achieve this is obviously to share data constantly. And it's not just about data, like I mentioned, but it's also about resources. So our real vision of this machine economy is always a real economy where devices do machine-to-machine transactions to trade with each other. So you can think of the future where one machine has access capability in something like, for example, storage or computational power or electricity. And that machine is able and willing to sell this excess resource to another machine which really needs it. And as such, we really enable this machine-to-machine interaction where one machine that has something sells it to another machine that needs it. And this whole trading of resources really happens on demand, on a per resource unit. And because it's on demand, you need to be able to pay per unit, pay per resource unit, pay per kilowatt that you use, pay per byte that you store or send through a gateway, or pay per byte, or pay per execution cycle, and so on and so forth. And the same can really be applied to the machines themselves, because we always argue that ownership is outdated. Because right now, or as in the future, why should you own an expensive drilling machine or an expensive car when all you care about is its utility? All you care about is getting from A to B or drilling a hole in your wall. And as such, you want to be able to lease those devices on demand and just pay per a mile that you drive or pay per drilling cycle that you do or whatever. With these micropayments, you get this predictability, and you can, for the first time in human history, you can really price resources for the actual unit that you utilize instead of having a subscription service or something like that. And the main reason why this is so incredibly powerful is that in the machine economy, a machine is no longer bound to its hardware. So we can have a tiny sensor, a tiny device. All it really needs is a wallet and connectivity, because this machine is now its own economic agent. So it's completely independent. And because of this concept of a machine economy where machines sell their excess resources, this tiny device is able to acquire the computational capacity of a supercomputer. And this whole fog computing and machine economy vision is really going to be the platform of a whole new era of applications to be built on top. Because now you as a developer no longer have to think in terms of hardware constrictions. And instead you can think much beyond that, like what kind of economic transaction can I enable to build my groundbreaking and disruptive application. And so we truly envision that IoT is going to be a platform where so many new applications are going to be built, and you can think of it like an app store in the future. So let's quickly dive into some use cases. So the beauty of IOTA is that it's actually the first a protocol that makes it possible to utilize it without any token. So even though we have a token which has a lot of value, to enable obviously those machine-to-machine payments, IOTA can also be utilized for data integrity. So as you see, most of the use cases that are happening today are focused on how do we secure data. So our big vision with IOTA is that it's really there to achieve the security of things, because the security of things is going to be needed for the adoption to happen in the first place, right? And IOTA makes it possible to secure data. So if you input data into the IOTA tangle, it's completely tamper-proof. So it can never be changed again. And through that, we really enable new applications and new trust to emerge from those transactions. So for example, we utilize this today for over-the-air updates. When you want to update your car, with IOTA, you now know the authenticity and the data integrity of this update that you're just about to do. Or we utilize it, for example, for an odometer use case where we want to secure the data inside the car itself. And also this whole notion of digital identities, they also rely on this data integrity. So for example, an attestation that your identity is real, let's say, for example, a bank attests that the identity of their millions of customers is real, they can utilize the IOTA Tangle to secure those attestations so that everyone in the future can look up, hey, the bank attested that my identity is real. And this is also incredibly interesting for liability management, which is why insurance companies really look into this quite deeply right now. So as I mentioned previously, right now we're actually working on a very interesting use case together with Innogy and with Volkswagen, focused on the secure audit trail of the cars. So it's also there to give cars a digital identity. So this digital twin, so that we have this identity of the car components, and through that we can start really securing the car itself and enable those car-to-car or car-to-infrastructure payments, so that the car can now pay an EV charging station, or that the car can pay for the toll station, and so on and so forth. And IOTA is being utilized for exactly this data integrity component and also the machine-to-machine payments. And another very interesting use case that we've been working on with Canonical and are now working on together with a very large telecom is this concept of bandwidth on demand. So think about not having a subscription service to a telecom, but instead you're able to connect to a gateway, a Wi-Fi hotspot or whatever, and you only pay per byte that you send and receive through that gateway. And that is incredibly interesting for machines in the future, because they're not going to have a subscription service. Instead, they want to be able to fluidly connect to a gateway and just pay for the connectivity that they need. And this is actually a project that we presented at the Mobile World Congress this year in Barcelona. And we're actually doing some very interesting thing with this for in-flight internet. Because you probably know, like, in-flight internet is fucking expensive. And with something like this, you're just able to send a picture that you want to send over WhatsApp or whatever. So it's quite interesting. And just to quickly mention, the way that we truly see this evolve is this prosumer aspect, so that you in the future can set up a gateway in your home and to say, hey, like, devices, if you want to connect to my gateway, here's how much money I'm going to charge you. And you as a consumer, you can now start setting up a Wi-Fi hotspot, and you will actually earn money with it, because machines will connect to it and they will pay you for the connectivity that you're providing to them. And this is actually a pretty big project that we're working on right now. Yeah. And another very interesting use case is the one called Paper API. So this is very interesting for banks, but also application developers. So imagine having your server infrastructure, your database, and usually you would obviously want to build a platform so that others can build on top of it, and they can start benefiting from the data that you've accumulated, that you've analyzed, and that you're storing locally. And what you can do with IOTA is that you can actually charge per API request that someone makes. So if someone makes an API request like, hey, can you analyze this picture for me? Your algorithm analyzes it, but you can able to charge per API request that you make. And the same can be applied to simple databases. Let's say, like, what is the current Forex price? Now you can start charging per API request that is being made. And that is really interesting, because this is a completely new business model that IOTA enables for companies. And yeah, so there's a lot more use cases that we're currently working on, but I sadly can't discuss them publicly yet. But we have some announcements lined up. And I think that the rest of this discussion, I think the last 50 minutes, we can spend on some interactive discussions. So if you guys have any questions, feel free to step up.
There are a few in the chat if you want to read through them.
Okay, sure. Let me do that. Why do you stick to IT? So one thing that should be noted, Mike, is that we don't just stick to IoT. So perhaps I should emphasize why IoT. So obviously the Internet of Things and this machine economy is going to be huge. Our argument is that it's going to be much, much bigger than our human economy in that sense. And the Internet of Things is really this green field. So the Internet of Things is something that has never been done before. What this means now is that we can come into this Internet of Things with a new protocol for machine-to-machine payments, which is IOTA. So we don't have to worry about any legacy systems like in the financial sector today. And we can also come into it with new hardware, which is why we've developed GIN, for example. And with this combination, we can truly conquer this IT space. And obviously, for example, we've recently made an announcement about our collaboration with RefUnite. So we don't just focus on machine to machine. We also see IOTA really as a truly powerful protocol for human to human payments, especially remittances, but also web payments. So our work with Satoshi Pay is also all about web payments. So why IoT? It's about focus, because we see a lot of potential in early adoption there. I guess it would result in a double spend. Oh, fuck. How should the merchant determine a stable price? So that is a very important question, Tom. Definitely. So that is also, I would argue, the major bottleneck when it comes to the adoption of cryptocurrencies as a real payment mechanism. Because today, quite frankly, cryptocurrencies are mainly for speculation. So what we have to achieve is, obviously, we want IOTA to be the true economic backbone of this machine economy. But in order to get there, we have this transition phase. And what we're working on right now is actually a way for merchants and for machines to have a fiat wallet. And when they make a transaction to another machine, this fiat balance is instantly converted into IOTA tokens. So euros and dollars are converted into US dollar, into fiat, into IOTA tokens. And those IOTA tokens are then being utilized to pay another machine. So the way that we see this evolve is, obviously, right now, this is mainly for the onboarding and offboarding, basically getting in and getting out. So initially, the focus is on helping this IOTA ecosystem to grow, to establish itself, and to then in the future to be able to say, hey, like those machines, they will no longer have a fiat balance, but instead they will have 50% of the entire value that they receive in IOTA tokens. And so through that, we have this transition phase of enabling true adoption for IOTA. Also, it should be noted that because of this system, IOTA doesn't have to worry about private blockchains. Because even though the value of Ethereum is so high today, no company utilizes either tokens. Instead, they just make their own tokens, their own private networks, and that is just not going to help in achieving a global economy, in achieving true adoption, because instead, everyone is just going to make their own private networks. And I would argue that that is going to be a huge hindrance to the adoption of Ethereum as well. So Raspberry Pi is definitely powerful enough for the proof of work. So this already works on the testnet today. So you can just connect your Raspberry Pi, and that's it basically. But it should be noted that the way that we see this transition is that we have this dedicated hardware for the proof of work. And obviously the Internet of Things is a hierarchical system. What this means is that not all devices are going to do proof of work. The beauty of IOTA is that we can quite easily decouple those three steps. So one machine can do the signing, which obviously has the wallet. Another machine can do the tip selection, and another machine can do the proof of work. And as such, we truly enable this whole IoT network to utilize IOTA without everyone being a full node, because that's not going to work anyways. So obviously the whole goal of this dedicated proof of work is that it will take a few milliseconds to a second. And because of that, we can achieve this true global effect. We can achieve this true global scalability and adoption of IOTA. So the whole goal of IOTA is that we have this dedicated hardware, those ASICs. So that's not just GIN, but it can be any integrated circuit. That has this dedicated IOTA hasher, and through that we have those clusters, which naturally emerge, and with that we want to achieve this vision of having thousands of transactions per second without any bottlenecks. So a snapshot. So that's a very good question. So first, let me describe what a snapshot is. A snapshot is something super simple. Basically, we aggregate all the transactions which happened in a certain time period, and we basically just aggregate them to address balances map. So we just check, hey, like this transaction sent value to an address. What is the latest state of this address? So snapshot is just the latest state of addresses with their respective balances. The beauty of this then is that we can delete the entire history. We can delete these gigabytes of data and no longer have to worry about it. Because at the end of the day, like, do you truly care about the full history all the time? You only care about the full history for special case scenarios. So to your second question, right now we have this kind of extraordinary case with the coordinator, which is in this training wheel period for IOTA. And because of that, right now snapshots are a global event. Because of that, the network is not down, by the way. Just the confirmations are down because the coordinator is shut off in this snapshot generation and validation period. The way that it's going to work in the future is, as I mentioned previously, we have those global clusters in the IOTA network. And those global clusters are then able to locally trigger a snapshot. And as such, snapshots in the future are no longer going to be a global event, but they're going to be a local event. So the entire network is not going to be disrupted by it, but only a smaller cluster of it is going to do it. Just have to browse through those questions. So there's no way that both transactions get confirmed in the subtangle and in the global network, by the way. One thing to emphasize is that in a local cluster, we can actually cheat other participants, because one thing to emphasize is that the local cluster has different security assumptions. Main assumption is that everyone has the same network connectivity. So everyone is offline. If someone is online, they can actually start cheating those local network participants. Obviously, they can't cheat the global network. They can only cheat the local network because of those asymmetric information flow, basically. Because someone else is connected to the global network and is able to spend transaction twice in the global network and in the local network. And that is also why, for example, we generally advise for local clusters to also utilize oracles, for example. So those oracles can be the bridge between the local cluster and the global network, and as such, you no longer have those security issues. So when it comes to turning off the coordinator, right now we're running a lot of simulations on that. The way that we want to achieve this is we want to coincide the turning off of the coordinator with the standardization of the IOTA protocol and the final design. So once that is set in motion, we will turn off the coordinator and through that have an actual IOTA tangle network. Because right now, IOTA still has some limitations, mainly because of this coordinator. Yeah. Yes, exactly. As more machines get added to the network, the faster the transactions get confirmed. So I have another 5 minutes, so let me just quickly read through the last one. Yeah, so I still work on liquid democracy, but it's mostly just conceptual work because I'm just too busy with work. But we're actually working on a very interesting use case around IOTA and voting. And IOTA could then very well be utilized as a backbone for liquid democracy. And I think there's some very interesting way to actually store the state of the relationships, like basically attestations, in the IOTA network. But if you're interested, we can actually work on that together, because I simply don't have enough time to work on that, but I'm really fascinated by it. Yeah, exactly. So obviously the way that we see IOTA is really as a backbone. It's really a protocol, and like how many people today know about TCP/IP? And it's the same with IOTA. We see IOTA as the true transaction settlement protocol for the internet and for the Internet of Things. And as such, in the future, people will probably not even know that they utilize IOTA, but they just do it, simply because of those fluid interactions that we are currently working on. So user experience is definitely also a big thing that we are focusing on to really achieve those fluid interactions and to also achieve this mass adoption. Because you probably know that, for example, in Bitcoin, we always used to joke like, hey, what is going to be the mainstream application? And it never happened, simply because there is no mainstream application yet. And as such, with IOTA, we truly want to get there. So the main selling point of IOTA is really, hey, we want to move away from proof of concepts and transition towards production-ready applications. because A, the protocol allows it, and B, we are truly building an ecosystem where we have those tools and those libraries that make it easy to develop with IOTA and to benefit from it. And that is kind of our end goal of this year, to really make IOTA easy to use and to see some real world applications being utilized by it already. So that is a very important question. So one thing, I think this is the last question that I'm going to answer. So one concept in IOTA is this concept of permanodes. So permanodes still store the full history. But here's the good thing about those permanodes. They actually can be independently validated. So you can still verify, hey, the data which those permanodes store, are they valid? Simply because what happens in a snapshot is we use Merkle trees to also group together those important data, those important transactions where you want to have the full data integrity forever. So to quickly answer your question, yes, the data is stored, but you can still verify it with those permanodes. And you as a company, because this data is important for you, you will obviously store the snapshot data because storage is super, super cheap. But the thing is that you can still verify the integrity of this database through those snapshots. And as such, you don't have to worry about it. So when will I be in Tokyo? I think that I'm going to be in Asia in October or November. I definitely want to come to Tokyo. So give me a reason to come, I guess. But yeah, so I think that's it for now. So if there's no other question, I think we can call this a successful session. Yes.
Super. Thank you very much, Dominik. This was super interesting, very enlightening, and absolutely educational. And so great to hear that you're actually coming to Tokyo. So maybe we can see you in person then as well.
Yeah, I absolutely want to come to. I kind of want to do an Asia trip. Well, once things are a bit smoother and the foundation is set up and so on and so forth. So definitely come to Tokyo if you do an Asia trip.
Super. Thanks again. It was great. Fantastic. Thank you.
Wonderful. All right. Thanks for your time, guys. Bye-bye.